Welcome back. So let's compare our implementation with the sklearn random forest implementation. But before we do so, we need to convert all the categorical features to numerical features because we have the same problem we had in the decision tree. If you remember from the last section, we said that we have a problem in decision trees implementation in sklearn is that it doesn't really accept categorical features. Okay, so we need to encode the categorical features as numerical features. So we use getDummies, and here we have xtrain encoded and we have xtest encoded. And if you remember also from the last section, we said that we need to drop this column, and we explained how we came up with this column and why we had this problem in the first place. After that, we will create an object of the random forest classifier class. And as you can see here, a random forest classifier. A random forest is a meta estimator that fits a number of decision tree classifier on various subsamples of the dataset and uses averaging to improve the predictive accuracy and control overfitting. The subsample size is always the same as the original input sample size, but the samples are drawn with replacement if bootstrap equal true, and this is by default. And we have all the parameters here, the hyperparameters, which we will discuss in the next lesson. So we created an object here, we use the fit function, and we use it on the xtrain encoded and the ytrain. And after that, we use the predict function or the predict method from this object, from this classifier object, and we use it on the xtest encoded. So we get the y prediction, and after that we use from the metrics the accuracy score between ytest and ypredict. So if we run this, let's see how long it will take. So I will not cut this part. As you can see, it took less than 10 seconds compared to maybe 1 minute or more using our implementation, because it's parallelizing the data and it's parallelizing the model. So each decision tree will run on its own and they will all run at the same time. So as you can see, the accuracy we got using the default hyperparameters is 48.4%, right? And we got almost 79 or 78.5, something like this, using our implementation. So there is a like 4 to 5% difference in the accuracy, but overall the results are comparable. Okay, so if we improved our implementation more and more, then maybe we can get even better results than the sklearn. Okay, so this is how we can compare our implementation with the sklearn implementation. As you can see, using sklearn you can do this in 1 line or maybe 3 lines, 3 to 4 lines. But our implementation, we had like 332 lines for the decision tree and around 200 or more lines for the random forest. And we did this because we want to understand how the algorithm works. Okay, so in the next lesson we will have a very brief discussion on the different hyperparameters we have in the random forest. They are very similar to the ones we discussed in the decision tree, but we will explain them also, or mention them at least. So in the next lesson we will do this, and in the lesson after that we will discuss the pros and the cons of random forests. So let's go.